Okay, so we've got our hypothesis test here and we're asked to find the critical region. So it's suspected that the probability of winning a game is less than 0.6. 20 games are played and the number of wins is recorded. So this is the data that we're going to get in order to help us test whether the probability of winning a game is actually less than 0.6 or not. So the first thing that we need to do is we need to define a variable, and I'm going to use capital X. And this is going to be the data that we get given in order to test this claim. So in this case, X is going to be the number of wins out of 20 games. Okay, and we know, let's say actually that P is the probability of winning a game. Now, we're asked to test whether someone thinks that the probability of winning a game is less than 0.6. So we know that our alternative hypothesis is that the probability is less than 0.6. And our null hypothesis is going to be actually the probability of winning the game is 0.6. Now, notice that x is going to be a binomial, going to follow a binomial distribution. Because you can think about this as we're doing 20 trials and each game has a probability of success, probability of winning of P. So X is going to follow binomial distribution with 20 trials and P is the probability of success. Now notice at this point that I'm leaving it as P. That's because we don't actually know what P is. That's what we're doing, that's what we're testing for in this hypothesis test. So what we're going to do is we're going to say, well, if H0 is true, and that the probability is just 0.6, then X will follow a binomial distribution, 20 trials, and the probability will be 0.6. And it's worth noting at this point that we would expect um, 20 times 0.6 wins, 60% of 20. Which is 12 wins. So basically we would expect X to be around about 12 if H0 is true. So let's look at this alternative hypothesis and try and work out what values of X are going to support this alternative hypothesis. Well, if the probability of success is actually less than 0.6, then we would expect significantly less than 12 wins because the probability of winning is less than 0.6. So here, small values of X support H1. And by small values of X, we mean significantly less than 12. And because of this, this is what we call a left tail test. Because we're looking at the left, the small values of the distribution. So we need to work out what the critical region is. Remember, the critical region is the values of X that support H1, so the small values of X. And we need to use a 5% significance level. So what this 5% significance level means is we need to be in the left 5% of the distribution. Okay? So let's try and draw a diagram of this distribution to try and help us think about what's going on here. So if we put on the horizontal axis our X values, so the number of wins, and on the vertical axis, the probability, I don't know what this distribution would actually look like, but I know that I could have 0 wins, 1 win, 2 wins, 3 wins, 4, 5, 6, etc. And my distribution is going to look something like this. And my highest probability is going to be around about 12 on my distribution, because that's the most that's what we'd expect. We'd expect 12. So that's what the distribution looks like. Okay. This distribution, this bar chart doesn't need to be accurate. I'm just drawing it to try and help us think about this critical region. So what we want to do is we want to find out what values of X are in the left 5% of the distribution. So we're just going to do a bit of trial and error and try a certain value of X. let's try x is less than or equal to 6. So let's suppose that our critical region is 6 or fewer, and let's work out what's the probability of being in that critical region. So the probability of x being less than or equal to 6. So you're going to go on statistics, distribution, binomial, cumulative, because we want less than or equal to. We're doing 20 trials, and we're assuming that h0 is true. So if h0 is true, then the probability is 0.6. Okay, and we want the probability of x being less than or equal to 6. So I've got lower as 0, upper as 6. You're just going to, because your calculator always has lower as 0, you just need to put x as 6. And that will give you the probability of getting 0 wins, 1 win, 2 wins, all the way up to 6 wins. And that probability is 0.65%. So what that means is that we are in the left 5% of the distribution. In fact, we're even more to the left than 5%. We're at 0.65% in this region. So what we can do is we can make our critical region a little bit bigger. We want it as close to 5% as possible, but no more than 5%. We're not allowed the probability of being in our critical region to be more than 5%, but we want to try and get as close to 5% as possible. So what that means is we can make our critical region a little bit bigger and include more x values. So what we could do is we could try the next value along, and actually let's try the probability of x being less than or equal to 7. So let's try that. Probability of x being less than or equal to 7. So if you just go to your calculator and change x to 7, you probably won't have lower as 0, you'll just have x is 7 in cumulative binomial, and you'll get 2.1%. So that's better. So what that means is this critical region to the region to the left of 7, and including 7, has a probability of 2.1%. So we are still in the left 5%, which is good. Let's see if we can get closer to 5% without going over it. So let's try x is less than or equal to 8, make the critical region a little bit bigger. If we do that, we'd get 5.7%. So this is too big. This would mean that our critical region there's a probability of being in our critical region, if h0 is true, is 5.7%, which is too big. So our critical region is going to be x is less than or equal to 7. So let's just remind ourselves what that means. That means that if I win 7 or fewer games out of the 20, then we're saying that's really unlikely. There's only a 2.1% chance that that happens if h0 is true. So if we do see these values of x, we're significantly lower than 12, what we'd expect if the probability is 0.6. So we can conclude that actually the probability of winning a game is less than 0.6. So this is going to be our rejection region, where we can reject h0 if x is less than or equal to 7.